Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to solve a problem in regression using Excel. Okay, so I'll share my computer screen with you. So we have data in the first two columns, columns A and B. Column A is X of the independent variable, which is in years, and column B, which is the dependent variable Y, wage gain percent. So this is basically showing you the percentage gain in wages with years of experience. So 12 years, 13 years, 14 years, 14, then 16, then 17, then 18 years of work experience and the wage gain percent. So we are going to do a regression analysis on this data set. So the first thing we will do is we'll click on File. Okay. Then we will go to options on the left column at the bottom. Okay. And in options, we are going to select add ins in the left column. And then in the left column, in the center, we have all this analysis tool pack, Excel add-in. Okay. So at the bottom, you have manage Excel add-in. Say, press on or click on go. And it should open up another window. I'm waiting for the window to open up. Okay, so I will click on Analysis Tool Pack, the first option, and click OK. Okay, so now if I click on, okay, now I want to do the regression, right? So the thing I will do is I have to reduce this. I have to click on the data. So I clicked on the data in the top panel, and then since I have already activated the data analysis tool pack, now I can click on data analysis. And I want to do a regression, basically. So I'll click on regression and then click OK. So data, click on data, then data analysis, then click on regression and say OK. The first thing it asks for input Y range. So my Y range is from B2, column B, cell 2, or row 2 through B8, column B, row 8. Okay. Then it asks for input X range. So put your cursor on there and click on from years from column A, row 2 through column A, row 8. Okay. Now notice the first row in both columns A and B are basically labels. Okay, so you have to tell Excel about it, so click on labels. Okay, now it is asking you, giving you different options. The first thing is you should keep it on new worksheet ply, and that's already actually highlighted. Next, we will click on residuals, and we will also click on residual plots. So what is residual? Residual is Y actual minus Y predicted. How do I get Y predicted? Y predicted is obtained by substituting or plugging in the values of the given X in the fitted line, best fit line, regression line. So plug in the value of X in those and you will get Y predicted or Y hat. So the difference between Y actual minus Y predicted gives you a residual. This is same as error. So error is y actual minus y predicted. Remember, some points will be above the fitted line, some points will be below the fitted line, best fit lines. So some of the errors will be positive when the y actual is above the fitted line, which is y predicted, and some of the residuals will be negative when y actual or the actual point is below the best fit line. Okay, so residuals will can be positive or negative. So what is residual plot? Residual plot is the plot of residual versus x. Okay, and deal is, or we do not want to see any particular pattern in the residual plot. If we see a particular pattern like residual increases with increasing value of x, or residual decreases with decreasing value of x, then the best fit line is not the best fit. Okay, so let's see what we get. So after I've clicked on everything, my output is coming on a new worksheet, and then I'm clicking OK. Okay, so first let's focus on the summary output. So the first line is multiple R. Multiple R is nothing but R is the correlation coefficient. Notice it is positive 0.997. It's strong positive correlation between X and Y. So we are climbing up the hill. As X increases, Y also increases. So R is called the correlation coefficient. Next line is R square. R square is called coefficient of determination. In this case, R square is 0.995. Only for R square, we multiply it by 100%. That means 99.5% of the variation in Y can be explained by the least square regression line. Okay. And remaining 0.5% cannot be explained. Okay, then we will focus on the equation of the best fit line. Intercept, so y hat intercept is minus 9.07 plus. Notice your R is positive, your slope will be positive too. The coefficient of years, remember years is the x variable. The coefficient of years is the slope, 1.571. Okay, and it gives you the residual plot too. Okay, and you see the residual plot has no particular trend. Some points are below, some points are above. This tells me that the best fit line is a good fit. Okay, so going back to the original data sheet, I can make an XY plot over here too. Okay, so what do I have to do? I go to insert, and then I go to insert, and then I go to the charts. Okay, and I will select the scatter plot. Okay, and I got a scatter plot. Suppose I want to find out the best fit line. Okay, what do I have to do? I have to right click on one of these data points and add a trend line. Click on add trend line. Okay, so add trend line. Notice the linear is already highlighted. We want to fit a straight line. Okay, also you can click on display equation on the chart and display R square value on the chart. So you will see the equation as well as the R square value, and you can move it over here. So notice the fitted line, Y predicted. It does not give you Y hat, but you have to assume it's Y hat, which is Y predicted is 1.57414x minus the intercept is 9.0714. Notice the R square value is 0.995. That means 99.5% of the variation in Y can be explained by the least square regression model. Okay, and remember the Y hat is the predicted value of Y. Okay, so what happens? What does that mean? That means if we plug in the value, substitute the different values of X starting from 12, then 13, etc. into the equation. So 1.5714. So I will do one calculation, for example. So let's take x value of 12, the first data point. So 1.5714 multiplied by 12 minus 9.0714 will give you the y predicted value of 9.785. So y actual minus y predicted is the residual. So for the first data point, the residual will be y actual is 10 minus the predicted is 9.785. The residual for the first data point is 0.215. And that's how the residuals are calculated, which you see in the residual plot over here. So if I little bit highlight or bring it over here, and you see, okay. So some of the residual uh, are positive, some are negative. The line in the middle is where the residual is 0. The horizontal line in the middle is where the residual is 0. So some of the residuals, some of the points are above the y equal to 0 line of the residual 0 line, and some of the points, diamonds, are below the residual line, which is fine. Okay, and you don't see any particular pattern in the residual plot, which tells me that the um, best fit line is a good fit for this data set. Okay, I will stop here today. If you have any question, comment, please write me a note. I'll get back to you as soon as possible. And if you like this video, please give me a thumbs up. I really appreciate that. And if you like this video, please share this video with your friends. And I'll come back next time with another interesting problem, interesting solution. Thanks for watching. Have a nice day. Take care. See you next time.